Hey everyone, welcome back to our edquest MLOps series. I'm your instructor, and if you have followed along so far, you now have your very own Kubernetes cluster up and running. Now it's time for the moment we have been waiting for, deploying an actual ML model on Kubernetes. So let's get into it. So what we will do in this session, we will package our ML model in Docker image, create a Kubernetes YAML files for deployment, expose the model using Kubernetes service, and test it via an endpoint. So let's go into the our VS Code. So these are our code basics. First, we will create a Docker file for the MLflow UI registry. So this is the Docker file you can use. Second, we have a model Docker file in which we will give the few packages requirement and expose the ports where we will register our model and expose those ports to the model serving part. So these are the code base like 05 ML deployment with Kubernetes. You can go and get pull this code base from edquest official, and then let's go back to our mobextem. So we will log into our local server. Okay, we have logged in. We have one directory for MLOps end to end. We'll just do the git pull for the fetching all those latest code changes. Yep, it is there. Now let's go into 05 model deployment with Kubernetes. We will just do the Docker file MLflow first, but I have already created these Docker images and pushed to our Docker Hub repository. These are the images which I have made from this Docker file and the model server as well. So on my Docker Hub repository, you can see I have build those Docker images, MLflow UI and ML model server. So I will not create these images again, and just let's go to deploy our MLflow registry UI. So cd kts sudo kubectl apply -f MLflow UI deployment.yaml. Okay, so kubectl get po. This MLflow registry is deployed. You can check the service as well. I have forwarded this to 32,000 because Kubernetes explicitly support 30,000 plus ports range. That's why we cannot expose to 5,000. You can expose, but you have to change the Kube API server YAML so that you can use the 5,000 and below ports as well. But explicitly latest Kubernetes supports the 30,000 plus ports range. So now let's go back to our MLflow UI. Just a minute. Okay, this one. This MLflow UI. So you can see we have no experiments, nothing is there. So now let's train our model. So I have already created a Python environment. So in this code base also we have the model code. So let's go into the model code, cd model code. I have already created a Python environment. So what we will do, we will activate that environment. So let's activate source MLOps. Okay, source MLOps. Let's home Ubuntu MLOps activate. Okay, now it is activated. We will execute this ice cream.py. This is a linear regression model in which we will just train the model on the basis of a temperature and the price range. If the temperature increases, the sale of the ice cream will be increased. So what we will do, just we will do the sudo python 3 ice cream.py. so let's see. Okay, let's have does not exist, create a new experiment. Okay, so you can see it has executed. Now back to MLflow UI, just refresh it. Yeah, you can see 18 seconds ago it has registered to the model. So we have this one in the models. it has created a model as well, version 1. So what we can do, we can give a alias so that it can be run in the, when we will start serving this model, and we will check the endpoints at the time we can get this alias name, so that it can acknowledge by the, we will acknowledge this by model serve. So we will give the one alias. So now we have given the alias. So that's all. Like you can see, we have deployed MLflow UI from Kubernetes, and we have trained a model on the local, and it has registered to that UI. So now let's deploy our model as well. Let's get back to the KTest part. So cd KTest, there is a config map as well, and our model deployment, right? So these are the two files. So first we will check with the config map, vi config map.yaml. So we have given our config map this tracking URI and model name as well. So first we will apply this config map, apply -f config map sudo. Okay, config map is created. Now we will deploy our model. So model deployment.yaml, it will create two services, one for serving, one for the node port accessibility, and other is for the model deployment. That will create a single pod. Sudo kubectl get po. You can see we have two pods are running, one is the UI, other is for the model deployment. Now we will check the service, sudo kubectl get svc. So there are three services created. One is for model service, that is a node port service which will be exposed to the 30080, and other one is for the internal communication. This service will be used for the prediction base. So when we will give the sample data to the model, it will predict the data with the accurate whatever the data we have used for the training the ice cream linear regression models. So it has deployed two services. One is for the earlier it was deployed for the UI part, that is 32,000. Okay, so now let's go back to our readme. We have few steps which I have written for the execution. Let's go back to, so you can see like we have the steps executed, what we have done. So firstly you have to create images for the MLflow UI and the model deployment, and then you can use those images to push on the Docker Hub repository, and you can use the pull, or you can use the import functionality of the container. So you can directly import those images to container, and whenever you will pull the images, I mean like whenever you deploy your MLflow UI or model deployment, it will just pull the images from container to CRI. So those things it will be done, and after that we will use this, whatever the deploying model, using model serving, it is supposed create a model, config map, deployment. From here we have done all those parts. This is HPA part, we will cover in the next session. Node port serve model. Okay, the deploy model to run the following command, node port serve model. So now we will execute this step number 9 to serve our model. So let's clear this screen and duplicate the session. We will just copy this curl command, and we will go back to the command line argument. We will just execute this as I said, like we will use the 30080 node port for serving our model. So this is the IP, that is local server IP, and 30080 server model. So it has started. Now let's check our kubectl get po. This is our model. Let's check its log, sudo kubectl logs -f. You can see it has started. It should start, right? It's giving the 200. Okay, and it is showing like, yeah, you can see this host command uv conserve, but this is the py func we are getting, right? So install dependency, and yeah, it is executed. The model is deployed. Now let's check our inferencing part, like prediction part. So for this, like, we can use the sample data, like a single dump data. So what we can do, let's check first the service ip, sudo kubectl get svc. So this is our the service ip, MLflow model service. This is the cluster ip, and we will execute to the port 80. So paste it. We will change our service ip, and that is our this service ip invocations, right? See, it has given the our prediction value 338. You can compare with the csv as well, like we can just replace this service ip with our new one and create a multiple inputs. So we will execute this one as well. Unmatched curl command 333. Okay, oh sorry, there is a replacement. Bracket 26 unmatched closed braces, where it is giving this error. Okay, sorry, there is a square bracket came in. This is the service ip. I need to copy, paste it again. Let's copy. See, it has given the input data like 33 degrees Celsius, 40 degrees Celsius, and 25 degrees Celsius. It is giving the price outcome. So yes, so it is giving us the inferencing as well. Okay, as you can see, you just have deployed your ML model in scalable cloud native using Kubernetes. Next, we will explore how to manage and scale workloads like a real DevOps engineer, rolling updates, making a replica sets, auto scaling, and more. So till that time, this is our ML model deployments using Kubernetes. So see you in the next one. Thank you.